The following video is about how to rotate polar graphs. So first we're going to graph r cosine theta equals 4. We see that line. We know that that's x equals 4. Now we're going to convert a new equation, r cosine of theta minus pi halves equals 4, into rectangular form and then graph that on the same grid. So if I'm going to do that, I need to remember some things about sine of a plus b and cosine of a plus b. We separate signs with the same sign, and the cosine coalition changes the sign. These are things that we have to remember from previous units. So in this problem, we see cosine of a minus b. So that's cosine a cosine b plus sine a sine b. It changes the sign. So we're going to have r times cosine of theta, cosine of pi halves, plus sine theta, sine of pi halves. Cosine of pi halves is equal to 0, and sine of pi halves is equal to 1. So when I simplify this, I end up with r sine theta equals 4, which is the same thing as y equals 4. So what I end up with is the line y equals 4. So x equals 4 turned into y equals 4. And we can probably figure out why that is. What ends up happening is I had some sort of shift. So theta shifted pi halves. Theta, this would have been called a translation in rectangular, but this is not a translation, so to speak, because we're dealing with angles. And so if an angle moves by pi halves, we're going to rotate the graph pi halves. So notice what happens is that if the coordinate that was tangent to the circle r equals 4 was over here, that point got rotated pi halves. And so notice that this is where r equals 4 still, but it got rotated pi halves counterclockwise. So if we see question 3, we're going to make a prediction that this will be r cosine theta rotated counterclockwise pi thirds. So that's our guess. So we're going to have it touching r equals 4 at theta equals pi thirds. And let's actually do the calculation to figure it out. So we use the cosine coalition, changes the sign, cosine theta, cosine pi thirds plus sine theta, sine pi thirds, times r equals 4. Then cosine of pi thirds is 1/2, and sine of pi thirds is root 3/2. Then if I distribute the r, I see that I have x here and y here. And I can convert that into standard form, well, as best as standard form can be without integer coefficients, because we can't get an integer. So x plus root 3y equals 8. So if I use the intercept method of graphing, I see that x would intercept at 8, y would intercept at 8 over root 3, which is 8 root 3 over 3. And I see that this line is exactly what that is. So we had a rotation of graph number 1's red line pi thirds counterclockwise. So our conclusion is that polar graphs have transformations just like rectangular graphs, but instead of transformations in rectangular graphs that would be translations, we actually realize that if we translate theta, it is a rotation around the origin. So let's see another example of this. R equals 4 sine theta is a circle of radius 2 going up in the y direction. We've learned that before, so just a reminder of y. If sine of theta equals y over r, I can replace that with y over r here, multiply the r over, and I get r squared equals 4y. Convert r squared to x squared plus y squared, and then do some completing the square math in order to get this equation, which we have known ever since geometry, where the center is at 0, 2, and the radius is 2. Now, we're going to convert this into rectangular and graph on the same grid. So just a reminder that sine of A plus B is sine A cosine B plus sine B cosine A. So I use the separate signs with the same sign formula. Remember that cosine and sine of pi fourths are both the same. It's root 2 over 2. So 4 times root 2 halves is equal to 2 root 2 in both cases. Sine and cosine are y over r and x over r respectively. Multiply the r over, and then change that to x squared plus y squared, do some subtractions, and complete the square. So when you divide this term by 2, you get root 2, and root 2 squared is 2. So if I add 2 twice, I'm actually adding 4, which I have to add on both sides. So I end up with x minus root 2 squared plus y minus root 2 squared equals 4. So if I graph that, I'll be at root 2 comma root 2, which should end up putting me right on this point, because root 2 squared plus root 2 squared is 2 plus 2, which is 4, which means that if I take the square root of it, the radius would again be 2. And so, if I graph this, notice that I get points at the origin, root 2 comma root 2, and then I have a point r equals 4, a point on the graph r equals 4, or on the circle r equals 4. But notice it was rotated from the original graph pi over 4, or pi fourths, clockwise. So if I look at number 7, which is not the same graph as above, but if I look at it, it's r equals 6 cosine theta plus pi thirds. So my thought is that I'm going to have the graph of r equals 6 cosine theta rotated pi thirds clockwise. So this is my graph that I'm thinking it's going to be. R equals 6 cosine theta would be a graph of radius 3 on the x-axis in the positive direction. So I do cosine coalition changes the sign. Cosine of pi thirds is 1/2, so 6 times a half gives me 3. Sine of pi thirds is root 3 halves, so 6 times that gives me 3 root 3. I change cosine to x over r and sine to y over r, multiply the r's over, change this to x squared plus y squared, subtract 3x, divide by 2 and square, add root 3 over, or root 3 y over to the left side, divide by 2 and square that. 9 fourths plus 27 fourths is 36 fourths, which is 9. So I added 9 to the left, I have to add 9 to the right. And so I end up with this graph, which is exactly what we graphed at 3 halves, 1.5. And then down here, it would be negative 3 root 3 over 2. So 1.5 negative 3 root 3 halves. So notice that I do get that exact same thing. What can I conclude? Positive shifts are counterclockwise and negative shifts are clockwise. Now when I say that, a positive shift would be something like theta minus pi halves or theta minus 2 pi thirds, because remember, when we're changing something on the inside of something, it's the opposite of what I see. So if I have a negative number that's a positive shift. And if I have something like theta plus pi fourths or theta plus 5 pi sixths, that would actually be a negative shift, because remember, when I change something on the inside with a variable, it's actually the opposite of what I see. We're going to convert this equation into rectangular form and then graph it. So I'm just going to change r squared to x squared plus y squared and r cosine theta into x. Then I complete the square. Well, it's actually completed for me because x squared plus 8x plus 16 is actually just x plus 4 squared. So this is going to be a graph of radius 5 centered at -4, 0. Now, using what we've already learned, all we're going to do is see that I have a pi halves counterclockwise rotation. So this is my thought. It's going to rotate counterclockwise to get me down here from this original graph. So I accidentally put this visible a little too early, but basically I use the cosine coalition, changes the sign. Cosine of pi halves is 0, sine of pi halves is 1. So I end up with 8y instead of 8x, and so I end up with x squared plus y plus 4 squared equals 25, which is an exact pi halves counterclockwise rotation of this graph. So notice if I moved it this way, counterclockwise pi halves, I end up with my center right here. Try these 3 problems on your own. Pause the video. So r sine theta plus 3 pi fourths equals 3. R equals 2 sine theta minus 2 pi thirds. And r squared plus 25 minus 10r cosine theta equals 9. Pause the video and see if you can get the answers. Here are the answers. So number 1 is just r sine theta equals 3 rotated 3 pi fourths clockwise. So that's a rotation in this direction. 2 is r equals 2 sine theta rotated 2 pi thirds counterclockwise. So that's rotated in this direction. And this one is just x minus 5 squared plus y squared equals 3. There was no rotation on this one, but the center is at 5, 0, and r is 3, so the radius is 3.